Good morning, Emeka. This is a champion. We're supposed to have our third lesson on Tuesday. I was a little busy, so I couldn't make it. So for today, we'll continue our lesson on digital and analog devices. Okay. Last week, Wednesday, we were able to know the difference between digital devices and analog devices. And I hope you still remember what we learned. We saw that digital devices are the devices that process data in the form of binary digits or binary code. And we said these codes are the zeros and ones that are being understood by the computer. Whenever you send something to the computer picks it as a binary digit and works on it before it gives out information. So we made mention of some of the examples of digital devices, and we said the computer is one of them. Okay. For analog devices, we said there are devices that measure data in the form of physical quantities. So we made mention of the barometer, the speedometer, the analog thermometer, and so on. For today's lesson, we'll be looking at the differences between analog and digital devices. And also look at how we can convert digital devices, so digital signals to analog signals, or analog signals to digital signals. By the end of this lesson, we should be able to know the difference between digital devices and analog devices. Okay, so let's look at how analog devices can be converted into analog signals can be converted to digital signals. Okay. The other time we met, I gave you an example that the microphone is an example of an analog device. Okay. And when the user uses a microphone, the wave that comes through the microphone comes in the form of analog waves. Okay. When you have a microphone connected to the speaker, the sound that goes through the speaker is in the form of analog waves. Okay. When it gets into the computer has 8 sound cards which convert the analog signals to a digital signals. Okay. So the sound will then go into the computer in the form of binary digits, that's the zeros and ones, which the computer will work on and give out information. Okay. In case it will come out in the form of sound, it will come through the speakers, which is then an analog signal. Okay. So let's have an image on how analog signals are being converted to digital signals. So on our screen, we can see a boy talking through a microphone. Okay. This microphone can only be connected to the computer through a sound card port. Okay, so this device we see over here is fixed on the motherboard. Okay, so if you connect this to the sound card and you talk through the microphone, the voice or the sound coming from the boy is in the form of analog signal, okay, or analog wave. When the sound gets into the microphone, it goes through the sound card over here. Okay, and we all know that the computer will never understand what the boy is saying unless it's being converted to a digital data or a digital signal. Okay, and this is done by using the sound card over here. So when the waves or the sound gets into the computer, immediately the sound card will take it and convert it to a form that the computer will understand, and that's the binary digit. Okay, so the wave that's coming here, which is in the continuous form, okay, will be converted into a binary code. Then the computer will work on that binary code and give out 8 information in the form of sound, which will come out through the speaker. Now let's look at the other one, how to convert digital signals to analog signals. Okay, so as I explained earlier on, when the waves get to the computer, the sound card will change it to a digital form or the binary digit. Okay, that's the zeros and ones. When it gets in and it wants to come out after processing of data, it will by all means comes out from the speaker. Okay, so the sound card will again work on the binary code and convert it to analog waves, which will come out through the speakers for the user to hear. That's why when you talk through the microphone, it is always converted into a different form, which is being amplified by the sound card, and it comes out from the speaker. Okay, so the conversion of the digital signal is being done mainly by the sound card inside the system unit, and it comes out through the speaker. Okay, so the sound card here can be considered as a digital and analog converter. Okay, that's the main device that changes digital waves or digital data to analog data, then analog data to digital data. Okay, now let's have a look at the difference between these two devices we're talking about. Here we have the difference between digital and analog devices. Okay, one main difference between the two is that from the definition I gave you, I said digital devices represent data in the form of binary digits. So here we can see that digital devices represent data in zeros and ones. That's the binary code or the binary digit. And we can also see that analog devices present data in terms of physical measurement. Okay. The next one, for digital devices, they represent data in its continuous form. That's a discrete form. Okay, they don't go into the computer, or they are not in the form of analog signals. Okay, so we can say that they are discontinuous. They come in the form of a certain values. Okay, then here we can also say that analog devices represent data in a continuous form. From the images we saw, okay, we saw that someone was talking through a microphone, and that wave goes in the form of a continuous wave. Okay, so all analog data and devices are in a continuous form. The next one, digital devices, they record analog waves and change them into binary digits. Okay, as we saw in our image, you can see that the computer was able to change analog waves into binary digits or digital data. Okay, but with analog devices, they record waves or signals as they are. When you talk through a microphone, the voice that comes from your mouth, okay, or the sound that comes from your mouth, that's how the devices will accept it. So they accept data or waves in the form in which it comes from. Okay. The next one, digital devices produce more accurate output than analog devices, and this is true. Okay, you always know that whenever you send a data into a computer, the result is what the user always expects. But with analog devices, there may be an error, okay, due to the surrounding or the environment in which the person is using the device. Okay, let's assume you are talking through a microphone and someone is also disturbing. The output that will come out will not be only your voice, but rather your voice together with the one that is in that particular environment. So analog devices always gives outputs that are not accurate. Okay. And the next one, we can also say that digital devices are able to process data faster than analog devices. Okay. Then with the analog devices, they process data in a slow or a slower form. Okay, they are slow in terms of data processing. So for today, this is where we end our lesson. Okay, with your third assignment, you have to give 4 differences between digital and analog devices. With the differences I gave, you write 4 of them. You create a nice table. Then at the left side, you can write digital devices or analog devices. Then on the other side, you write analog devices or digital devices. then you number them with alphabet ABC, okay, up to D. Then you write the differences. If you write digital devices process data in the form of binary digit, okay, then you write analog devices represent data in the form of physical quantity. They should match, okay, it will be the same. If this one is tall, this one will be short, so you compare them in that way. The next one, we sketch a diagram showing the conversion of analog signal to digital signal. So with the image I showed you, this image, you make a sketch of it, okay, for question number 2. We will end here. I'll prepare your lesson for tomorrow in the morning and send it to you. Goodbye.